Year 7 Simplifying Algebraic Expressions. This is part 1 of the content on simplifying algebraic expressions. So we're going to start off by talking about collecting like terms. Now, like terms are terms which are of the same form. So a really simple example here is question 1. We have a plus a plus a plus a plus a. We can simplify that algebraically as 5a, 5 lots of a. And because all the a terms are like terms, they can be collected. Second example, similar sort of idea, 3p plus 7p, that gives us 10 lots of p. And because these are both simple p terms, they can be collected. Same with number 3, 10x take away 8x simply gives us 2x. So these terms can be added or subtracted because they're the same term, the same types of term. Now, we hit a problem in number 4 because b and 7 are two different types of term. They cannot be collected together. So this does not simplify. You will find some people try and say that the answer is 7b, but that means 7 times b, which is not the same as b plus 7. The only other way in which you might want to write this is 7 plus b rather than b plus 7, but you can't simplify it further. Same with question 5, you've got an a term and a number term, so they do not simplify. You have a lot of people who sometimes try and simplify this to 6a, but it wouldn't work because it's 12a take away 6. You can't just take the 12 down to 6 because that is not a 12 on its own, it's 12a. Now, if the question had been 12a take away 6a, you then have like terms and it simplifies down to 6a, but that's not the case here. Question 6, again, these are unlike terms, so this does not simplify. If you wanted to, you could write this as 7b plus 3a, but there's nothing else that we could do with this, really. Number 7, an interesting one. Look at the two different letters here. Because that's a capital A and because that's a lower k, they're not considered to be like terms, so this does not simplify. And that's the same with question 8. Although in English, a lowercase b and a capital B are essentially the same letter, in algebra, they represent different terms, so this does not simplify. Now, question 9, 7y take away y. When you have a letter on its own like that, it means you have one lot of it. 7y take away y is 6y. Now, I often see the incorrect answer of 7 in a question like this because people think subtracting y means getting rid of the y value in the first term. That's not the case. 7y take away 1y takes you down to 6y. So you're going to have a go at simplifying each of these expressions. They are taken from an exercise in the textbook. Pause the video, have a go, and then check your answers through. If an expression does not simplify, simply write it down and state does not simplify. So here are the answers, and anything with a cross next to it is an expression that cannot be simplified because the terms are unlike terms. We can only collect together like terms. So just to emphasize this point once more, look at example 1. You have 3a and 5a. They are like terms. They can be collected. Look at a different example. Let's say number 14, 6m plus 5n. These are unlike terms, m and n, so this cannot be simplified any further. Now let's look at a series of more complex examples. Now, I recommend taking 2 different colours as you look through each of these examples and work through them. I'm going to highlight in question 1 the like terms. Now there is a golden rule here. Every term owns the sign that comes directly in front of it. So that's not just a 5x, that's a plus 5x. That's not just an 8, it's a positive 8 and then a positive 10 here. So let's collect the like terms here. We know we can collect 3x and 5x to give us 8x, and we know we can collect 8 and 10 to give us a positive 18. So this first expression simplifies down to give us 8x plus 18. Let's do the same thing in the next one. I can collect a 4a and a positive 3a. I can collect a 5b, which is a positive 5b, and a positive 2b. So collecting the a terms, we get 7a. Collecting the b terms, we get 7b. Now, question 3, we start to include negative numbers in our work, so we have to be careful. Here is a 12x, and note, because there's no sign in front of it, it does actually mean it's a positive 12x there, and a positive 3x. And then we have a positive 10, but a negative 9. Now, 12x plus 3x, the red circled terms, give us 15x. 10 minus 9 gives us a positive 1. Let's try this on question 4. I'm going to circle 4a and minus 3a, and I'm going to circle positive 6 and positive 1. Now, 4a minus 3a gives me a single a, and I won't write 1a, I'm going to write a. Now, 6 plus a 1 gives me a plus 7. Here is my answer. And I'm collecting my like terms to simplify the more complex expression on the left to the simpler expression on the right. Question 5, let's circle 7x minus 5x, and let's carefully circle positive 2 and negative 8. Now 7x take away 5x gives us 2x. Positive 2 minus 8 gives us negative 6. Now we just simply write the negative 6. Do not write 2x add a negative 6. That's a really messy way of writing out an answer, and plus minus together like that simply means minus, so we may as well just write 2x minus 6. That is the best answer here. So this is why you have to be very careful with your negatives. So next one, we have 8p minus 6p being combined, and minus 5 being combined with positive 3. Now 8p minus 6p gives us 2p. Minus 5 plus a 3 gives us minus 2. Do not write plus minus 2, just write negative 2, because that's what happens when you combine negative 5 and positive 3. Number 7, 2x plus 7x, they can be combined. Plus 5y minus 10y, they can be combined. Now 2x plus 7x gives us 9x. Plus 5y minus 10y, well, that is going to give us minus 5y. Again, do not write plus minus 5y as your second part of your expression. You've got a positive 5y and a minus 10y. That simply gives you a minus 5y to include in the second part of your expression here. Number 8, 3a and a 9 minus 2a, minus 6b and a plus 12b. Look at the red parts first of all. 3a minus 2a gives you one lot of a, or just a. Minus 6b plus a 12b, well, if you're on minus 6 and you add 12, you get all the way up to 6b. Question 9, we have a 5, a positive 5 at the start, being combined with a negative 7. We then have a positive 2m being combined with a negative 6m. 5 minus 7 gives me negative 2. And then the blue parts, 2m minus 6m gives me a negative 4m. Do not write plus minus 4m, just write the minus 4m, because that's what 2m and minus 6m combine to give us. Number 10, cannot be simplified. Did you spot this? Now, it's tempting to try and do it, but these are not like terms. This term contains just an x, this term contains an x squared, and this term contains an xy. So these are unlike terms, which means we cannot collect them to simplify the expression. It has to stay as it is. You are now going to have to go at some questions from the textbook, page 113. From exercise 2e, you need to work through all the questions. The answers are here below for you to check your work as you go along, or after you finish the questions. I recommend doing a question, checking the question, then moving on. If you have any corrections, you must go back and complete them. Don't just copy down the correct answer, work out where you've gone wrong, ask if you need any help.